right, well, let's chat a little bit about new stuff. Though it's going to look a lot like what we just did on Friday. So remember on Friday, we did the simplifying rational expressions where we factored everything and canceled out the common factors, divided out the common factors. We're going to do the same kind of thing today. It's just that we're going to have multiplication and division to start with, and then still do the exact same thing, divide out common factors. So you've done this before with fractions. So let's talk about the same idea with fractions. So in this case, we've got this example of 4/12 times 8/20. I'm going to do this a little bit elongated so we can see what the process is, so that you can see how this mirrors what we're going to do for rational expressions. So in the 4 in that numerator, we know we can write that as 2 times 2, right? We'll multiply that out. The 12 we could write as 4 times 3, which would be 2 times 2 times 3. Oops. The 8 we could write as 4 times 2, or I'll write it as 2 times 2 times 2. Like I said, you wouldn't necessarily do this all the time. I'm just showing you what you would do and mirror what we're going to do here in a minute. Okay? And then 20 is 4 times 5, or 2 times 2 times 5. Okay. So this is exactly what we said when we did when we were doing the problems on Friday, right? You took your expressions and factored it as much as you could. That's exactly what I did with these numbers right now, right? I factored them as much as I could, right? All right. So now when we cancel things out or divide things out, since it's all multiplication, we can divide wherever we like. Well, I see 2's here and 2's here, but it really, if I wanted to get rid of these 2's, I could get rid of this 2 here with that one, right? There's nothing wrong with that if I want to do it that way, right? I could crisscross them a little bit with multiplication, right? I could do this one with that one if I wanted to, as long as I'm doing one on top and one on bottom, right? I could do this one with this one. The whole idea with this is as long as you see a factor on top and on bottom, as long as it's multiplication, I can cancel wherever I want to, right? So I've got 4 of these 2's on top and 4 of them on bottom. I can divide them all out. Is there anything else that divides out in this case? No? So how do we multiply? And the reason why all this works, of course, is how do you multiply fractions? You just multiply across the top, multiply across the bottom. So again, as long as there's common factors on top and bottom and everything is multiplied, we can just divide out common factors in any of the fractions that we would like. It has to be multiplication. Let's see if we can remind ourselves of something different. Maybe if we did, let's say you did 3/14 divided by, let's say, 9/7. So let's say we did division instead. How do you handle division when you have fractions? What do you do? When we divide, what do we do when we divide by a fraction? We change the division into a multiplication. And what do you do with the second one? Flip it, right? Take the reciprocal. Remember, when you divide by a fraction, it changes into multiplication by the reciprocal. And now again, we look for common factors. We can write 14 as 2 times 7. We can write the 9 as 3 times 3. Do you see anything that divides out in this case? Yeah, one of the 3 here will get one of these, right? Leaves a 1 when we divide that one out. What else does? The 7's. There's a 1 here. And then again, what do we get for the answer? We multiply across. On top, we'll get maybe 1 over 6. Good. On top, we'll get 1. On bottom, we'll get a 6. So we get 1 over 6. Again, the whole premise of this is factor everything in sight, divide out the common factors. Okay? All right, so let's see if we can apply this then to rational expressions. Let's look at this first one. We have this x squared plus 7x plus 10 over x squared plus 12x plus 35. And then that's times the other two, the x squared plus 13x plus 42 over the x squared plus 15x plus 54. So just like what we did yesterday, what we did on Friday, factor everything you can. That's step 1. Okay? How does that x squared plus 7x plus 10 factor? How does that first part factor? X plus 2? Yep. So again, since it's x squared, we want x and x, right? 10, I need things that multiply to 10 and give me 7 when I add them. So 2 and 5 will work. On bottom, again, we have x squared. So we have x and x. We need things that multiply to 35 and add to 12. What works? X plus 5 and x plus 7. Good. Now I need x squared again. That gives me x and x. We want things that multiply to give you 42 and add to give you 13. Yeah, 7 and 6 work. Good. Finally, we need things that multiply to give you 54 and add to 15. Yeah, 6 and 9. Good. If you need to use AC method, please do. That's fine. It's a little bit easier when you've got a leading coefficient of 1, right? You don't have to worry about what multiplies to give you that last number and adds to give you the middle number. All right, since everything here is multiplied now, this is multiplication. Since everything is multiplied, we can divide out common factors. What do you see divides out here? X plus 5 does. What else divides out? Yeah, the x plus 6's do, and what else does? The 7's, right? Those are in the same fraction. This is like last time, right? They were in the same fraction. Those divided out. The x plus 6's are also in the same fraction. That those divide out. The 7's are kind of crisscrossed, but since everything's multiplied together, it's like they're in the same fraction. So we can those divide out as well. We can get rid of those. What are you left with? Yeah, the x plus 2 over the x plus 9. Exactly. Now again, just be very, very careful. These do not divide out, these x's, right? It has to be multiplied. We cannot divide out individual terms. Okay? These are entire factors that we're dividing out. Okay? Or entire factors that we're canceling. Okay? These x's you can't do anything with. Okay? This is the case. All right. The next problem is almost exactly the same, except that we've got division instead of multiplication. The very first thing I would do in this case, I just rewrite it as multiplication. And then do it like we just did the previous problem. When you divide, what do we do instead? We change division to multiplication. And what do we do with the second one? Flip it. Yeah. And now attack that problem just like we did the previous one. Work on that one for a minute, and then we'll talk about it. Ready to chat about this one? Yes, no. Ready? You? Okay. Again, now that we've written it as a multiplication problem, our goal here is to factor everything that we can and divide out common factors on top and bottom. Okay. How does that first numerator, that first, the top of the first fraction factor? Okay. Again, since it's just an x squared, oops, that's a 3. Since it's just an x squared, it makes it a little bit easier to factor, right? We're looking for things that multiply to give you 15 and add to give you 8, 5, and 3 work, right? How about the denominator? What does it factor as? Good, x plus 5 and x minus 2. Again, since I have x squared, I know we just use x and x here. It needs to multiply to negative 10. So I'm going to use one positive and one negative. And since it's going to add to plus 3, we'd have a plus 5 and a minus 2. Okay. What about the numerator of the second one? What about the top of the second one? Good. A minus 2 and a plus 9. Everybody see that one? Same idea, right? Multiply to negative 18, so one has to be positive and one has to be negative. Add it up to positive 7. Pardon me. And finally, the denominator. An x minus 7 and an x plus 3. Are we okay with the factors? Okay. Now again, we're looking for things that divide out, right? Factors that divide out. What do you see divides out? Yeah, the minus 2's do. Good. Yeah, the x plus 5's do, and the x plus 3's do, right? We agree? Yeah, nothing else divides out, so what are we left with at the end? Yep. Good, x plus 9 over x minus 7, exactly. Pardon. That okay? Are we happy with that? All right, let's do one more together, and then I'll turn you loose on the worksheet. Let's look at, let's do C together. Just to remind ourselves of how we factor those. Again, this one's multiplication, so I don't have to worry about rewriting the division, right? The reason I want to go through this one is that different form. I see that x squared minus 9. What kind of a form does that have? See? Yeah, so we call that a what again? The difference of squares. Good. Right? That's a difference of squares, yes? So how does that top factor for that one? Good. Good. X plus 3, x minus 3. Good. Exactly right. Goodness gracious. How does the bottom factor for that first one? Good. Again, it's that leading coefficient of 1, so I just need things that multiply to 18 and give you 9, right? Second fraction, how does that factor? The top? Good. X plus 6 and x plus 2. And then the bottom, what is the bottom again? X minus 2x plus 2. Good. This is the difference of squares again, right? Yeah. No, it has to be a minus. Yeah, if it's a plus, it doesn't factor. Yeah, if it's an x squared plus 9 or x squared plus 4, it wouldn't factor. All right, so what cancels now? What factors are divides out now? X plus 6 does. X plus 2 does. And the x plus 3 does. Good. And we're left with what? Good, good. That's exactly right. So again, this is our entire, notice that it's literally the same stuff we did last time, right? The only difference is that if you have a division, I can rewrite it as multiplication first and then do the exact same process. Okay? All right. Well, go ahead and start working on the other ones. I'll post up solutions as we go. Holler at me if you got questions, all that good stuff. Goodness gracious.